Welcome to the software journey with GKey. Data warehousing concepts with real-time interview questions and answers. Lesson number 21. What are performance tuning and optimization techniques, which covers DB performance, ETL performance, BI performance in data warehousing. In this part of training, we are going to discuss about what are performance tuning and optimization techniques in data warehousing. The performance tuning and optimization things which used to happen at the database level and ETL level. First, we will discuss about the performance tuning and optimization techniques in database. That means database performance things. In database performance, we will be having different things. First, we will discuss about partitioning. Database performance means for storing the data in tables, we will be having different databases like SQL Server, Oracle, Sybase, Teradata, something like that. In that, partitioning is one of the concepts for database performance. Partitioning splits a big table into smaller pieces like partitions, typically by date, region, range or hash keys. Benefits of this partitioning is faster queries, scan, fewer partitions, easier maintenance, that is load drop one partition, better manageability. For example, if we have 3 million of records for a particular table, we can divide that table into different partitions. On parallel, we can load the data or we can retrieve the data from different partitions. In such a way, the data is going to get faster performance. These kind of situations, we are going for partitioning in databases. Coming to the logical diagram for the partition is a logical table is fact sales. All years of sales, it is a huge table. We can divide the data into different years like 2019, 20, 21. If I have any query for 2021 data, the query is directly comes here. The data is going to be pulled. If there is no partitioning, then the query is getting to the main data set and it will look through all 3 lakhs or 3 years data and it will get the desired result. Then it will take more time. By doing this kind of a partitioning, we can have database performance. And in database performance, next point is indexing strategies. Let us see what are indexes. Indexes speed up reads by allowing faster lookups. There are different types of indexes: clustered index, non-clustered index, cover index and column store index. Clustered index defines physical order of the table. Non-clustered index separate structure with key plus pointer. Cover index include all columns needed by a query. Column store index, columnar storage for data warehouse. These things I have explained in database concepts like SQL Server, database, interview questions and answers. You can go and see for the detailed information. The strategy behind the indexing thing is index joins keys and common filters, avoids too many indexes on heavy insert tables, use composite indexes for multi-column filters. For example, indexes are works like index page in a book. If you want to get into a particular chapter, you can go for the index page and you can directly jump to that particular page number instead of scanning all the pages in the table. Index diagram here is table customer, table index on email. This is the direct seek, here no seek. That means if you create index on an email in a customer table, if you fire any query, it will directly get into the email. If you are not having any index, it will just get into the customer table. It will scan all the columns in the table. That is called full scan. It is a direct seek. That means it will directly get into the email column. Here the customer ID, name, email, index on email means it will directly get into the email where it will get into all the columns that I have explained. That is about a full scan and direct seek. Direct seek means if you mention any particular column in an index, it will directly get into that column if mentioned in the select query. Otherwise, it will scan whole table for full scanning to get the desired result. And the next concept is materialized views. A materialized view is a pre-computed and stored result of a query, unlike normal view which is a virtual. That means the normal views which are created based on the base table. Coming to the benefits of materialized view, it is great for complex joins and aggregations, can be refreshed, fast refresh and incremental in some databases. For example, create materialized view. This is the view name, as this is a syntax like a query. Based on this query, we have created a materialized view. Queries on daily sales hits this view instead of scanning fact sales. That means instead of getting into the base table, it will just get into this view. Fact sales, it may have 100 million rows, whereas materialized view, it will be having a limited number of rows per year. If you have any query on this materialized view, it is going to be get the data faster compared to the query on a base table. These are called materialized views, which are in SQL for BI. And coming to last concept or next concept, that is compression. Compression means row or page or columnar reduces storage and input and output. For this, less disk usage, database reads fewer pages and faster scans, CPU overhead for compression or decompression, usually worth it for data warehouse. Especially these are effective, these compressions are effective for repeated values like dimension keys and statuses and large fact tables. In this way, the compression reduces storage and input-output memory things. Coming to the next concept, that is ETL performance. The first concept is database performance. Now there is an ETL layer also involved in data warehousing. Here we'll see the performance techniques which are involved in ETL performance. There, the first one is push down optimization. Push calculations into databases instead of doing them row by row in the ETL tool. Once we connect to the source systems, if we extract the data, the calculations instead of doing in the ETL part, we can push them to the database side. In the queries level, the calculations are going to be happened. They are called push down optimization. From ETL, the calculations are pushed into database. This is called push down optimization. For example, instead of looping in SSIS or ADF to calculate totals, use a single SQL insert and select with the joins and aggregations. Without push down, source ETL, these things used to happen. If push down, that things are going to happen in the source itself. Benefits of a push down optimization is uses database engines optimization execution, reduce data movement on ETL part. All these calculations are going to happen from the database side instead of ETL layer. And coming to the ETL performance, next concept is parallel processing. Run multiple tasks at the same time. Parallel file loads, multiple partition loaded concurrently, parallel dimension and fact loads. Here, in the data warehousing, we will be having different fact and dimension tables. Instead of loading the tables sequentially, we can load the tables parallelly in such a way the process will get faster and loads also completes in the desired time. That is called a parallel processing, which is available for ETL performance in ETL layer. Coming to the third point, that is bulk loads in ETL performance. Use bulk insert method rather than a row by row insert. In ETL like SSIS, we have bulk insert task also. By using that task, we can load the data bulk without reading the data row by row. SQL Server bulk insert dot BPC, SSIS fact load. These are different things are available in SQL Server. BCP is the utility. By using this one, we can load in SSIS fast load. SSIS also we have an option called Fast load. SSIS means SQL Server Integration Services, which is an ETL tool. In Oracle, SQL Loader, it can be used for the bulk loads. And columnar data warehouse, copy Redshift. Redshift is one of the database. Here also we have the concept. Load data for Synapses, BigQuery and Snowflake US. Coming to the features of a bulk load, minimum logging, batch inserts, disabled constraints and indexes during the load. When you are doing a bulk inserts, first we have to disable the constraints and indexes on a particular table. We have to load and again you have to create these things. These things can be achieved in ETL layer by using different component options available. And coming to the last thing, that is BI performance. We have seen like database performance, ETL performance, and finally the BI performance, that is business intelligence performance, that is reporting layer performance. Here first one would be aggregation tables. We already saw the concept in 6.1, here used specifically for speed. Aggregation tables are used specifically for speed. Create a summaries table for frequently used queries, sales by year and month region, inventory by product or month. These are the different examples that we can go for aggregation tables. BI tools points to these tables or use them automatically. Instead of having individual things, we can create aggregate tables and we can put this kind of data into those tables, and BI tools points to these tables instead of pointing to the individual metrics, and the reports will load faster by using aggregate tables. Coming to the diagram, fact table which may have 100 million rows, whereas pre-aggregation sales monthly region few thousand rows, whereas coming to the dashboard, monthly sales region. If you create a dashboard instead of fact sales on a pre-aggregated table, the dashboard displays data faster. I think you got some idea about aggregation table here in BI performance. And next point in BI performance is cube optimization. For MOLAP, HOLAP tabular models which are available in SSIS, that is SQL Server Analysis Services, design a proper hierarchies year, quarter, month, and use attribute relationship, pre-process and pre-aggregate hot combinations, remove unused columns and measures, optimize partitions one per year or month. In this way, cube optimization also we can do, and we can get the performance in BA performance concepts. And coming to this slide and the diagram from cube partitions, cube can be partition based on different metrics. Here we have taken year-wise partition. This cube has partition on 2019, 2020, 2021. Process query frequently. Here each year's data is going to be stored, their aggregations and values in that. If you fire any query on top of this year, that will get that decide year aggregations. These are like pre-aggregations on most used dimensions. That means instead of calculating things on the fly when you are trying to display the report values, we can go for the pre-aggregations on mostly used dimension tables. And in BI performance, third point is aggregations. Whether SQL, DAX or MDX, filter early, reduce rows before joining and grouping, avoid row by row operations like cursor, scalar, user defined functions. Use star schema patterns. Why? Because there are very less choice in star schemas. Only select needed columns. That means we have to select only needed. Instead of going for select star, we can select only the columns which we require. And in DAX means data analysis expressions which are available for Power BI. To avoid overly complex row context, use variables and measure branching. These are the points which are used in SQL part, DAX part and MDX. SQL is for database, DAX is for Power BI reporting or visualization tool, MDX is for SSAS, which is SQL Server Analysis Services. And logical flow is select star from join or something. This would be bad. Why? Because we are selecting by using star all columns. Here we are going to select what are the columns we needed. Here it will be good for performance. Coming to the final slide, super condensed summary. BI fundamentals, semantic layer simplifies data, dashboards, ad hoc reports, and drill down and aggregations are available in BI fundamentals that we have discussed in the beginning stage. And SQL for BI, Windows functions, ranking, aggregations, CTEs, main toolbox for complex analytical queries from the database side. And DB performance, partitioning, indexing, materialized views, compression, faster storage layer. And for the ETL performance, push down, parallelism, bulk loads, these are for fast data movement. And finally, BI performance, aggregation tables, optimized cubes, and tuned queries, which are for fast dashboarding. I think you got some idea about performance tuning and optimization techniques which are available at different layers like database side, ETL side, and reporting or BI side. I think you got some idea about these concepts. Thank you.
Follow us on YouTube, LinkedIn, Instagram, and Facebook. Don't forget to like, share, subscribe, and press the bell icon to stay updated with our latest content. Join the GKey community and grow your IT profession with us.